Today we are going to do the review problems. We're going to make a key on the review questions that I asked you to do on 7.1 to 7.4. And now that begins on page 520, 521. So on page 521, we're going to do number 2. Then we're going to do 4 through 6. We're going to do 8 through 12. And then I want you to do 14 through 20 even, and then 22 through 26. Okay, so what I want you to do is pause it, walk through these questions. So do number 2, and then pause the video, start it up, and let's check it together. Okay, go ahead and pause the video and do question number 2. Okay, for starters on question number 2. On number 2 it says f of x is equal to 1/5 times 0.2 raised to the x power. Now, first of all, this 0.2 tells me it's going to decay. Now remember, if it increases, if it is bigger than 1, and it decreases if it's between 0 and 1. So, because 0.2 is between 0 and 1, it's going to decay. Now, let's take a look at this 1/5 here. What does this 1/5 do? The 1/5 means it's going to vertically shrink it. So, if we're going to graph this equation, the graph is going to look like this, and I am going to, okay, this is going to be a 2, and 1, 2, 3, okay. Alright, so what's going to happen is it's going to shrink, and it's going to go through right about right there. So this function is going to come down, and then it's going to become asymptotic to the x-axis. Okay, so the asymptote is actually going to be right here. So that asymptote is going to be y equals 0, and that's number 2. Okay, go ahead and pause it and go to the next question. Alright, let's go to number 4. Now that you've worked through question number 4, and if you haven't done it already, pause it and work through it. But for number 4, it says f of x is equal to 6.4 times 1 3/8 raised to the x. Now, in taking a look at this one here, first of all, okay, right here, we see it's going to be 1 3/8. Now, what's going to happen there, horizontally, it's going to stretch it out a little bit because it's 1 3/8. Okay, so it's just going to stretch it out a little. Now, right here, I see it 6.4, so that means it's going to vertically stretch it a little bit. Matter of fact, it's going to stretch it so it crosses the y-axis at 6.4. So if we graph this function, let's say this is 2, 4, 6, 8, 10. So 246.4, let's say, is about right there. And it's going to cross right there. Now, because this number right here is greater than 1, that means it's going to be a growth. Okay. Now, the asymptote is still going to be right here along the x-axis. So that's going to be y equals 0. And that function is going to look something like this, and it's going to be asymptotic to the line y equals 0. Okay, and of course, it is a growth. All right, go ahead and pause it and do the next question. Okay, for question number 5, it says, suppose that the number of bacteria in a culture was 1,000 on Monday, and then the number has been increasing at a rate of 50% per day since then. Okay, now this problem here shows a 50% growth per day. All right, now when you normally look at this one here, you might think, oh, that's going to be apert. But actually, it's not. Okay? It says it grows at a rate of 50% per day. Okay? That's the piece where it's going to throw something at you. A little bit different than what you might think. This formula we're going to be using here in this situation is actually where you have, it's going to be something like this. It's going to be the amount is equal to P times the original amount, well, not the original amount, but 1 plus the growth rate, all raised to the number of days that we have been culturing the bacteria. Okay, so this is a little bit different formula here. Okay, so let's go ahead and look at this here. So if I write it as a formula, A is equal to, my original amount is 1,000, and then it's going to be 1 plus 0.5 raised to the t. Okay, so I could write this as A is equal to 1,000 times 1.5 raised to the t. And if you want to, you can put parentheses there. Okay, so that is part A. All right, now for part B, we just plug in. They want to know how many what the bacteria rate is going to be 7 days later. So you just plug it in. So, oh, I probably should do something. That A, I noticed I put an A there. I probably should write it as a function. So that means it should be A of t, like that. So A of t. All right, so in this one I have A of 7 is going to be equal to 1,000 times 1.5 raised to the 7. Therefore, A of 7, or the amount after 7 days, is going to be approximately equal to, so let's use the approximately equal to sign, and if you plug it into your calculator, you get 17,086 bacteria. All right, so as a sentence, here's the way you want to write it. You want to say after 7 days, the culture will have 17,086 bacteria. All right, go ahead and pause it and move on to question 6. Okay, for number 6, we're going to graph the relation, then we're going to graph its inverse. Okay, so let's go ahead and graph this, and we're going to graph it on the same coordinate plane. So let's go ahead and just do this quickly. So we're going to go like this. And it looks like I need to go out to 16, so I'm going to go by 2s. 2, 4, 6, 8, 10, 12, 14, and 16. And up here I want to go 2, 4, 6, 8, 10, 12, 14, 16 there. Okay, so this is going to be 16 there, and this is going to be 16 up here. So now, in looking at this one here, let's first graph. It's going to be, okay, then let's see, there's a -1 and a -2. So I need to go -1, 0. So let's graph this one, -1, 0. Then I'm going to be 0 and 2, 4. So I'm right there. I'm at 1 and I'm 2, 4, 6, 8. So I'm right there. And I'm at 3. Let's see, I'm at, oops, you know what? I went by 2, so let me fix that real quick. So it's going to be 1, 2, 4, 6, 8, so it's going to be right there. And then at 2, it's going to be up at 12, 2, 4, 6, 8, 10, 12, so it's going to be right there. And then at 3, I'm going to be up at 16, which is about right there. Okay, so that graphs that. Now, we're going to do the inverse of this. Now, when you're creating the inverse of this, you have to interchange the x and y. So, I am going to have 0, 4, 8, 12, 16, and I'm also going to have -1, 0, 1, 2, and 3. So now I'm just going to graph this, and this again, let me just write inverse there so we all recognize that's the inverse. So I'm going to, now let's do this in a lighter yellow. So I'm going to be 0, negative 1. So let's go down to negative, oops, I just noticed something else. That should have been a negative 4 right there. Okay, so let's go down to negative 4 here. Okay, so I'm at, it says I'm at 0, negative 1, so we're going to put a dot right there. Then I'm going to be at 4, 0, so 2, 4, 0, dot right there. Then I'm going to be at 8, 1, 2, 4, 6, 8, 1, so I'm going to put a dot right there. And then I'm going to go 12, 2, so 2, 4, 6, 8, 10, 12, 2, put a dot right there. And lastly, I'm going to go out to 16 and I'm going to put a 3. Now, the nice thing with this is it should be a reflection over top of the line y equals x. So I should see a relationship right here. You know, and the relationship is seen. So notice these points right here, right along there, should reflect. So this point goes with this point with this point, and so on and so forth, all the way through. So it's a reflection over the line, y equals x. All right, that was number 6. All right, go on to the next question. Okay, now that you've worked through number 8, and if you haven't worked through it, go ahead and work through it and then come back to the explanation. But for number 8, it says graph each function, then write and graph the inverse. Okay, so first of all, let's find the inverse. So I have f of x is equal to x plus 2.1. So our steps for finding the inverse. First thing you do is you change f of x to a y. So y equals x plus 2.1. Then I'm going to interchange the x and y. So x is equal to y plus 2.1. Now I'm going to solve for y. So we're going to subtract 2.1 to both sides. And I will get, and I'm going to put y on the left side, so it's going to be x minus 2.1. All right, now let's graph these two functions. In graphing the first one, I see that, let me here first of all, so I'm going to be 1, 2, 3, 4. That should work okay. 1, 2, 3, and a 4 up there. Okay, so it says, let me go 1, 2, 3, 4, and 1, 2, 3, 4. All right, so in looking at this here, let's graph the first one, and the first one is this one right here. So it's going to be up at a 2.1, which is just about right there is where the y-intercept is, and the slope is up 1 over 1. So let's see, I am going to go up 1 over 1, so the graph should run just something like that, kind of sketching it out. Okay, now for the inverse of that, oh, I forgot to do one little thing. After, right here at this level, after you solve for y again, then you have to change y to f inverse of x is equal to x minus 2.1. So we're going to start here at negative 2.1 right there. And I'm going to go up 1 over 1 and so on and so forth, and the graph looks just like this. Now, notice the two lines are a reflection over the line y equals x, which runs right down the center. So this is y equals x. Okay, so there's the graph and its inverse. Okay, go ahead and pause it and work through the next question. All right, let's begin looking at number 9. Again, if you haven't done it yet, go ahead and pause it. You work through it. But number 9 says f of x is equal to 3 over 4 minus x. Okay, so let's find the inverse first. First of all, we go y equals 3 over 4 minus x. Interchange x and y, so x is equal to 3 over 4 minus y. So what I'm going to do here is I'm going to subtract x over to this side, and I'm going to add y over to this side. And in doing so, I get y is equal to 3 over 4 minus x, or f inverse of x is equal to 3 over 4 minus x. Okay, so there finds the inverse. Okay, so let's real quickly sketch this graph out. So as I sketch out the graph, let's see. Let's go 1, 2, 1, 2. We don't need to go very large because this graph only, well, it doesn't go out very large. Okay, so I'm going to start at a y-intercept of 3/4, which is right there. Okay, and it's going to, I see the slope is -1, so I'm going to go down 1 over 1, and so on and so forth. So that graph is going to look just like that. Okay, now, if I take that graph and reflect it, notice I'm going to reflect it over this line, y equals x, just like that. Notice what happens to this line. Yes, this line right here, it's going to reflect, but when I flip it over, it's going to fall right on top of each other. So its inverse is right on top of the original function. All right, there's number 9. Go on to number 10, so go ahead and pause it as you work number 10. Okay, now that you've worked through number 10 says, again we have f of x is equal to 5x plus a 4. We're going to, let's see, replace f of x with y. So y equals a 5x plus a 4. Interchange the x and y. So I get x is equal to 5y plus a 4. Now I'm going to solve for this right here. So to do that I need to subtract a 4 to both sides. So I get x minus 4 equals 5y. Divide by 5. And I'm going to put the y on the left side. So y is equal to x minus 4. Now if you want to, matter of fact, let's just do it. Let's distribute the 5 to the x and to the -4. So it's going to be 1/5 x minus 4/5. Alright, and lastly we're going to go f inverse of x is equal to 1/5 times x minus a 4/5. Alright, so let's go ahead and just quickly graph this. Let's see here. With all these, you know, I'm going to go 1/5 at a time. So I'm going to go 1. No, I'm not. Well, let's just go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I may regret what I just did. Maybe not. 1, 2, 3, 4, and a 5. 1, 2, 3, 4, 5. Okay, so first of all, the first graph, we're going to graph this one right here. So it's going to be 1, 2, 3, 4. It crosses right there. My slope is up 5 over 1 to the right, or I can go down 5 over 1 to the left. So that's what I'm going to do. So 1, 2, 3, 4, 5 over 1. Puts the dot right there. And the graph for this function looks just like this. Okay, now let's do the other one. The other one here, I see it's going to be at -4/5. So it's almost -1. Okay, so it's right there. And we're going to go up 1 over 5. So we're going to go up 1 and over 1, 2, 3, 4, 5. So it's going to put a dot right there. Alright, so in looking at this, I can see that that graph is going to look something just like this. Now, notice, does this look like a reflection over the line y equals x? And I would say it sure does. Alright guys, that was number 10. Go ahead, pause it, and you work through number 11. Okay, on number 11, first thing that you had to do was distribute that 4 inside. So you should have gotten f of x is equal to 1 over 5x plus 3/5. Okay, so now let's walk through it. So y is equal to 1 over 5x plus 3 over 5. Okay, we're going to interchange x and y. So x is equal to 1/5 y equals 3, plus 3/5. Let me fix that. Okay, so plus 3/5. Okay, we're going to subtract 3/5 to both sides first. So x minus 3 over 5 equals 1 over 5y. Now we're going to multiply everything on both sides by a 5. And I will get y is equal to 5x. If I distribute this 5 in, that gives me just a minus 3. And then we have f inverse of x is equal to 5x minus 3. Alright, so now let's graph this thing real quickly here. So let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Alright, so we're going to go from scale it like so. And let's see here. First of all, looking at this one right here, here is my slope, here is my y-intercept. So I'm going to be at 3/5, which is going to be about, and just approximate it right in there, 3/5. And then I'm going to go up 1 over 1, 2, 3, 4, and 5. So it's going to be about right there. Okay, so now let's just sketch a graph so it looks something like this. On the next one, I see it's going to be 1, 2, 3. It's going to be negative 3 like this. And then I see it's going to be 1, 2, 3, 4, 5 over 1. So it's going to be like that. And that graph is going to come down and look something like that. Okay, now take a look at it and ask yourself, does this look like a reflection over the line y equals x? And I would say, yep, it does. Okay, so that's number 11. Go on to number 12, and in number 12, what does it say? It says, Rebecca's computer repair bill includes $210 for parts, $50 per hour for labor. Her bill can be expressed as a function of hours, x, for f of x equals 210 plus 55x. Find the inverse function, use it to find the number of hours of labor if her bill was $402.50. Okay, so guys, in looking at this, don't be afraid because it's just word problems. It really isn't. You just have a problem that says, what gives you an equation, just like the previous 8, 9, 10, 11 did. Find the inverse, and then just plug 402.50 in for the, well, you ask, is it x or y? Well, in the domain, it will be y, but I mean in the original function, you're going to plug, that'll be your y, which means in the inverse function, you're going to plug it in for the, all right, that's enough hint. You take it from there, pause the video, and we'll come back and look at it here in a few moments. Okay, guys, let's go ahead and take a look at problem number 12. Problem number 12, okay. All right, so we have f of x is equal to 210 plus 55x. Replacing the f of x with the y, 210 plus 55x. Interchange x and y. X is equal to 210 plus 55. Y. Now we're going to solve for y. So I'm going to subtract 210 to both sides, giving us x minus 210 equals 55y. Divide everything on both sides by 55, and I have y, or I'm going to just skip a step and go f inverse of x is equal to x minus 210 all over 55. Now, here's what I'm going to do. We want to plug in 402.50 and determine how many hours the person worked on the computer. Okay, so we're going to say f inverse of 402.5 is equal to 402.5 minus 210 all over 55. Now we plug that into our computer and we get that to be 3.5 hours. So as a sentence, you're going to write the person worked on the computer 3.5 hours to produce a bill of $402.50. Okay, that's number 12. go ahead on and do the next question. Okay, folks, all right, looking at number 14. Again, if you haven't done it, pause the video, work it out. If you have, here it is, 17.6 to the 0 power equals a 1. Now, you have to remember, if I had log base b of a equals x, okay, remember that went to, now, you have to remember here, the base of the log becomes the base of the exponent, and then remember what I said, inside, outside, trade places. Okay, so that means b to the x equals a. And we can go both ways with that. Okay, so let's go ahead and look to see what I have. I have an exponential equation. What is the base of the exponent? 17.6. So that's going to become the base of the, yes, you said it, the log. And then the inside, outside is going to change places. So that gives me the log base 17.6 of 1 equals 0. All right, that's number 14. All right, let's go to number 16 next. Pause the video, and then we'll work through it. Okay, let's take a look at number 16. Number 16 says, we have 0.5 to the x equals 0.0625. Okay, again, look right here. The base of the exponent becomes the base of the log, inside, outside, trade places. So I am going to have log base 0.5 of 0.0625 equals x. And there's our answer. All right. You go ahead, work number 18, then play me here in a moment. All right, let's take a look at number 18. Number 18 says, we have log of 1 base 1/5 of 25 equaling a -2. Okay, and it says, write the logarithmic equation in exponential form. Okay, so again, look here. The base of the log becomes the base of the exponent, so that means it's going to be 1/5. And then I see the inside, outside trade places, so it's going to be a -2 there equals to a 25. All right, pause me, and you do number 20. Okay, number 20, it says log base e. Now, you could write it log base e like it shows there, or you could write it as ln of x. Okay, so again, base of the log becomes the base of the exponent, so it's going to be e. And then, of course, inside, outside, trade places, right here. So it's going to be e to the 5th equals x, and that is number 20. Okay, guys, number 21 is next. Pause the video and do what it says. Let me read what it says firstly. It says graph f of x equals 5, 6 to the x. It gives you what the domain values are. I want you to take your graphing calculator, plug in those domain values into that function. F of x equals 5 over 6 to the x. Find the range values, then inverse those, and then graph both of them. Okay, pause it and you work it out. All right, let's work through this one together. It says f of x is equal to 5 over 6 raised to the x power. Okay, so first of all, let's go ahead and put this out here. We'll do a chart, so I have -1, 0, 1, 2, and 3. Okay, now, for -1, I get 1.2. For 0, I get 1. For 1, I get 0.8333. So 0.8, and I want to go to the 4th decimal point, which tells me I need to spread this out a little bit. So let's go ahead and just spread this out a little bit. So 0.8333. Then I'm going to plug in a 2. When I plug in a 2, I get 0.6944. So 0.6944. And then when I plug in a what's the next one? 3. For a 3, I get 0.5687. 0.5687. 787. Okay. All right, so now we're going to find the inverse. So the inverse of this is going to just be flipping that around. So here I will get 1.2 and negative 1. Then I'm going to get 1.8333 and 0. Then I'm going to, oops, sorry guys, let me fix that. I get 0, I get a 1. Okay, now, alright, now for 1 I get 0.8333. For 2 I get 0.6944. And for 3 I will get 0.5787. Alrighty, now let's go ahead and graph them both. And we're going to just graph them on the same coordinate plane. Okay, so let's see here. I go between, okay, so we need to go 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. And 1, 2, and negative 3 down there. Okay, so first of all, let's use this color yellow. So I'm at negative 1, and I'm about 1.2, so right there. And then I go 0 at 1, and then I'm at 1, I'm 0.8333. At 2, I'm 0.6994. At 3, I'm 0.5787. Okay, so there's that one. Now, let's use a lighter yellow. On the other, when I'm at 1.2, I'm at negative 1. Okay, when I'm at 1, I'm at 0. When I'm at 0.883, I'm at 1. When I'm at 0.69, I'm up at 2. And when I'm at 0.57, I'm up at 3. So it's kind of like that. So the idea is, does that look like it's a reflection over this? And, well, you know what? I kind of draw that line a little bit crooked, but I think you got the idea that it will be. All right, guys, let's move on to the next question. Pause the video and do the next question. Okay, let's take a look at number 22 next. Okay, for number 22, it says log base 3 of 81 plus log base 3 of 9. And it says express as a single logarithm. Simplify if possible. Okay, so in looking at this one here, let's see what I can do here. Well, first of all, what do I see? I see a plus there, and I see log base 3, log base 3. So let me ask the way I do in class. How many logs do I see? 2. How many do you want to see? 1, you say. That is correct. Plus means what? Yes, multiplication. So we are going to have log base 3 of 81 times 9, or log base 3 of 729. Now, that right there, I can simplify this because it says simplify if possible. Well, it turns out that 3 to the 6th power is 729. So I have log base 3 of 3 to the 6th power. And when you have the base of your log being the same as the base of the exponent, what happens? Yes, they log out, leaving you with 6 as a final answer. All right, that takes care of for 22. You go on to on to the next one. Pause the video, please. Okay, 23 is next. So if you haven't done it, pause the video. And if you have, let's look at it together. So I have log of 1 over 5 of 25 plus log of 1/5 again of 5. Okay, so I see here, what is it? I have, how many logs do I see? 2. How many logs do I want to see? 1. I see a plus there, so plus means multiplication. So yes, so that gives me log of 1 over 5, and then I have 25 times 5. Now 25 times 5 is 125, so that's log 1 over 5 of 125. Now, let's think with me a second here. Let's see. This is going to be log of 1/5. And let's see, I could make this 1/5, and 5 to the what power? Yes, 3. Okay, but if I throw that 5 in the denominator like it is, it's going to be a -3 there. So now I've manipulated it so the base of my log is the same as the base of my exponent, and it logs out, leaving me with an answer of -3. All right, that's 23. On to 24. Pause it, and please work it. All right, let's go on to 24. In looking at number 24, it says log of 1.2 of 2.16, and then I see minus log of 1.2 of 1.5. All right, again, I look here, I see 2 logs, which I don't want to see. I see a subtraction, so I'm going to make it a single log. So log of 1.2, we're going to take 2.16 divided by 1.5, which comes out 1.44. So I have log base 1.2 raised to the log base 1.2 of 1.44. All right, now we need to play with this here. Now this is kind of a tricky one. You kind of have to play it with your calculator, but you realize that 1.2 squared is equal to 1.44. So you have log base 1.2 of 1.2 squared. Now you've manipulated it. It logs out, leaving me with an answer of 2. And that covers number 24. 2 more to go. Number 25. Go ahead and work on number 25. Okay, and looking at question number 25, this is what I see. It says log base 4 of 256 squared. Couple ways you could do this. You could take 256 and square it. Or you could realize log base 4, I could take this 2, I could pull it out front, so it would be 2 times log base 4, and 256 is 4 to the 4th power. Now if I do that, this logs out, leaving me with 2 times, this 4 drops down to ground level, and 2 times 4 is, you said it, 8. And that's all there is to number 25. Okay, guys, number 26. We made it. Last question. Whew, my goodness. Okay, so number 26 says, now, again, if you haven't worked it, pause it up, and then play me here in a moment when you have it finished. If you are done, stay with me. Okay, here it is. Number 26 says log base 7 of 343. Now, is it possible to write this as log base 7 of 7 to some power? We'll start playing with it. Go 7 times 7 times 7 and so on until you get 343. Turns out 7 to the 3rd power is 343. So again, this logs out, leaving us with 3. Ta-da! We are finito. Okay, guys, this wraps up the 7.1 through 7.4 review. If you have further questions, bring them to class. And guys, I'll see you in class.